This chapter introduces a new topic, which is relational operators. But before we get to relational operators, let's review real quickly what we have done so far. We have seen three different data structures. And data structures are places that you can put your data in whatever form it is. And those three data structures are a vector, a matrix, and an array. Now the next question is, what are you going to put in those data structures? And I refer to those as data types. And the data types that we have encountered so far, starting with that from the least amount of information to the greatest, the null is basically an empty data structure. There's nothing in it. That's followed by a logical, and logicals are true or false, all set in uppercase. The next is an integer, and the way you put an integer into R is you type the integer itself and follow that by a capital L. The next one up is a floating point number, which R refers to as a numeric. And then above that is going to be a complex number, which is referred to as complex. And finally, if you have a character string, that contains the most information of all. So that is a review of data structures, which is the way you can arrange data, and the different things that you can put into those data structures, which is data types. So now we're starting out on relational operators, and there are 6 of them that we're going to cover in this chapter. The first is less than. The second is less than or equal to. The third is greater than. The next is greater than or equal to. And then when you put in a double equal, that is testing for equality. And the not equal to is a exclamation point and an equal to, and that is how you check for not equal or inequality. So those are the 6, and here is a quick example to illustrate how they're used. First of all, set a vector to a bunch of numeric values, and just to keep it simple here, I will have them all as integers. So 3, -8, 0, 5. There is my vector x. You can look in the upper right-hand window and you'll see it is a numeric. It has one subscript, which ranges from 1 through 4, and those are the elements of the 4-element vector. If I type x down here in the console, I will get the contents of x. First thing I'm going to do is I am going to check and see if any of the elements of x are equal to 7. Now what's going on here is you have a vector of length 4 on the left-hand side, and you have a vector of length 1 on the right-hand side. So R knows to recycle, and we've seen recycling before, and it will take that 7 and it will turn it into a vector of length 7. So you can think of that right-hand side as 7, 7, 7, 7. Now what it's going to do is it's going to compare one element after another. It's going to compare 3 with 7, and 3 is not equal to 7, so that'll return a false. And then it'll compare -8 with 7, that's also false. And then 0 with 7, and then 5 with 7. And when you hit return, you get 4 falses here. Let's try another example. Let's say we want to compare x to 5. Well, once again, the 5 gets recycled, and it will be 5, 5, 5, 5. And you will do compairwise comparisons, and this time you'll get 3 falses followed by a true, because the 5th element of both, or the 4th element of both vectors is equal to 5. Another thing you can do is you can say x not equal to 0. And again, the 0 gets recycled, and all 4 of those elements get compared and ask if they are non-zero. And 3 of the 4 of them are non-zero, so you get 3 trues and a false. Another thing that you can do is you can check and see which ones are negative. So x less than 0, again, the 0 gets recycled 4 times, and it turns out just one of them, namely -8, is a negative number. You can, if you want to, put these into the C function. So I could say C of x equals 0, comma, x not equal to 0. In this particular case, what's going to happen is x double equals 0 will be a string of 4 logicals. X not equal to 0 will also be a string of 4 logicals. And when you hit return, you will get 8 logical elements, the first 4 asking if the values of x are equal to 0, and the last 4 asking if the elements of x are non-zero. Another thing that you can do is you can do the following. You can take x less than 0, which you can see from 2 commands above, gives you this vector of logicals, and you can say every single time I see a true in that vector, I am going to take the elements of x and replace them by 17. So if you come up and take a look at x, it's currently 3, -8, 0, 5, and when you execute the setting of a value of x to 17, but only for the value that's coming in here as a true, that -8, which is up here, is going to get replaced by 17. Keep in mind, you're used to putting in numeric values for subscripts. R also accepts logical values for subscripts as it is working here. So when I hit return after this statement, it'll do that silently, but when I now look at x, instead of being 3, -8, 0, and 5, it is now 3, 17, 0, and 5. It just makes the replacement. There is another command. I will clear the screen first that can be used, and that command is used to compare things other than numerics. For example, if I want to compare the letter C with the letter R, I can compare them in this fashion. So what this asks is, how does the string C compare to the string R? Clearly they're different strings, but is it in fact less than R? When you hit return, it'll come back and say true. That is to say that the ASCII numbering of C is less than the ASCII numbering for R. Here's another thing you can do. If x is 3, 17, 0, and 5, I can set a vector y also to be 4 elements. And let's go with 5, -2, 6, and 9. When I set up the vector in that fashion, and I compare x greater than y, let me display y first. I say, where is x greater than y? It will do a pairwise comparison. So what it's going to do is it's going to compare 3 and 5, and 3 is not greater than 5, so that will return a false. And then what it'll do is it'll compare 17 and -2, and 17 is greater than -2, so it'll return a true. When you hit return here, let's see if we can back this up, it will return false, true, false, false, as it does those pairwise comparisons. Here's another thing that you can do. You can say the following: show me the values of x such that x is greater than y. Again, as a subscript, you're feeding in false, true, false, false. It will only display those that are true. The x value where this is true is the 17. The 17 is the only element of the vector that is greater than the corresponding element of y. when you hit return here, what you will have is just 17 show up. Another thing I could do is I could say take the values of x such that x is greater than y, and take those values and double them, multiply them by 2. Well, we know there's only one element, 17, where x exceeds y, so when you hit return there, it will do it silently. But now when you look at x, rather than being 3, 17, 0, and 5, it's now 3, 34, 0, and 5. So that's how you compare two vectors, x and y, for example. You can also compare matrices, arrays, etc. There is a function that can be of some use, and let me type x here, and it's the which function. If I ask this question, which values of x are less than 4? What which will do is it will tell you the subscripts, namely it's the first and third subscripts, of the values which satisfy this condition x less than 4. Here's an example of where that can be used with a slightly more complicated function call inside of which. I could say which values of x are less than the mean of x. And it turns out the first, the third, and the fourth values are less than the mean of x. I can check real quick here. What's the mean of x? It's 10.5, and you can see the first and the third and the fourth values of x are less than that mean, and it will return their subscripts. As an application of this, let's assume that I have a few vectors of varying data types. So let me start out with name, and I will pick some short 3-letter names such as Joe, Ian, Liz, and Ollie. Now with those in place, and you can see up here in the upper right, I now have a vector of 4 elements, and in those elements are characters, and they are Joe, Ian, Liz, and Ollie. Let me do another thing in here. Let's put their age. We got the names, and here are the ages. If these are college students, this might be 19, 21, 18, and 20. And finally, let's ask one more question. Let's ask if they are from Virginia. And let's say Joe is from Virginia, whereas Ian is not from Virginia, Liz is from Virginia, and Ollie is not from Virginia. So those vectors are now all set up. So we've got names, we've got ages, and we've got their status in terms of whether or not they are from Virginia. And I can do the following. I can say name sub, and then I can put in a condition. And let's put in the following condition. Age less than 21. So those would be those age 18, 19, and 20 in our data set. And then what I'm going to do is I'm going to put in the AND operator. And what that will do is it will do a vectorize and we're going to say VA is equal to true. What this would give us is those that are less than age 21 and are from Virginia, and their names will be, and it's complaining. Why is it complaining? Name sub, oh, I made an error here. That right there is an assignment. We don't want assignment. What we want is we want to compare the two, and that's the double equals. So in this case, we find out that Joe and Liz, since Joe is 19 and Liz is 18, and they both have trues here, those are the two names of the students that are from Virginia and under 21. This could be shortened in the following fashion. So this condition, I have VA double equals true. I really don't need that because VA is already a logical, a vector of logicals. So if I just put in VA, it will come back and say that's true, false, and it will give me exactly the same result in this particular case. Joe and Liz. The very last thing I'm going to do is introduce you to something known as the if-else. This is kind of an early move towards programming, but here's how it works. I can take the vector x here, and I can do the following. I can say if-else, and I can put in a condition. And maybe my condition is absolute value of x is greater than 4. Now, if the absolute value of x is greater than 4, then I can do one of two things. If that condition is true, and that's what we have in this yellow dialog box here, if there is a yes that is returned, then I can do one thing. And what I'll do is I will return the phrase large magnitude. But if the absolute value of x is less than 4, then I will say small magnitude. And that's an example of if-else. So once again, to review, if-else starts with a condition. If that condition is true, it will do whatever is in this first field. If that condition is false, it will do whatever is in this field. We are feeding it a vector x, and x is a 4-element vector of numerics. So we will take the absolute value of all of these, and in this case that does nothing because they're all positive already. And if they are greater than 4, and there are two of them greater than 4, 5 and 34, then it will say large magnitude, and if not, it will say small magnitude. And so what you get is 3 and 0 both get a string small magnitude, and 34 and 5 both get the string large magnitude. There are more examples of if-else and relational operators in the book, and so this is a good time to get into R and experiment with these things and try some examples and then change them a small bit and see how all of that works.